Hello, so today we are going to take a look at this problem called number of ones not on boundary or not on boundaries. Yeah, we can call it either one of these. And essentially the problem is we get a matrix of 1 and zeros, and here 0 would represent water and 1 would represent land. And the allowed moves that we have is moving in 4 directions, either up, down, left, or right, to another cell that also has value 1. So we can move from a land cell to another land cell in one of the 4 directions, up, down, left, right. And the goal here is to return the number of lands squares, but with one additional condition, that which is that cannot move off the boundary in any number of moves. What this means is basically, if we look at this example here, this one here, it means that this one should not be counted because it's at the boundary. But these ones here and this one can be counted because they don't, like, you can't move from them to the boundaries. But if we had 1 here, right, which means from this one you can walk left, left, left until you walk off the boundary, that means that we shouldn't count all of these, and we shouldn't count this one as well, because then that would mean we go up and then go left until we walk off the boundary. So this is not, we won't count it. But since in this example we have 0 here, we can count them, and with that we have 1, 2, 3, so we have 3 ones, right? This one here doesn't count again because it's at the boundary. If we had another one here, still it won't count because it's you can walk left and walk off the boundary like that with this one. But if we had 0 here, then this one would count, right? Because you can't walk off the boundaries from it by moving using the rules that we said here, right? So with this original matrix here, we have just 3 ones, and so we just return 3, the number of land squares from which we can't walk off the boundary. Okay, so this is the definition of the problem. Now let's see how we can solve it. Okay, so let's see how we can solve this problem. So let's take the first example that we had, which is that we have a matrix like this. So we would have 4 zeros first, and then we'd have 2 ones, and then we'd have 0, 0, 1, 0, and then after that we'd have 1, 0, 0, 0, right? So this is our matrix here. It's called A. And what we want is to count all the ones that don't reach any boundary with value 1. So that's essentially what the problem is asking. And so let's write it down to help us a little bit here. So what we want is the number of ones, cells, that can't move to a boundary that has value 1, right? Okay, this is pretty much what we want. So we could think of this a little bit differently. So if we can, of course, this, like, we know that if somehow we just, if we take another example, let's say something where we have 1, 1, 1, maybe 1, 1, and then maybe we have 1 here, and then maybe 0, 0, something really big, 1, 0, 0, 1, 1, something like this, right? And you could imagine that the empty places are zeros, right? And then we have 0, 0 maybe here, and then 0, 1, 0, 1, 0. I'll say this is 0 as well. 0, 1 here, 0, 0, right? Right. So you could see here, let me just continue here, 1, 0, 0, 0, right? So we have 0, 0, 0, 0, 0, right? So from this here, one thing we could see is that the ones that we work are these ones here, because they can't reach the boundary with value 1. This one also works because it can't reach boundary 1. Remember, the only moves that we have are go up, down, left, and right, right? These are the only moves allowed. But these here, right, don't work for us. These as well don't work for us because, for example, this one, it can reach this boundary here, so we can't count it. And so we could think about this, well, what if we did a first, let's say we do a first DFS pass that fluid fills all ones reachable from a boundary 1 of value 1, reachable from a boundary of value 1 to 0, right? Just turn it to 0. So that would mean that what will happen here is that we will turn these here, right? So we could just take these here, turn them to 0, fluid fill them to 0. Since this is at the boundary, we'll start from it. This is at the boundary, we'll start from it. And we will fluid fill, which means basically with DFS, we will keep going with traversing with DFS using the notion of the neighbors being going left, right, up, and down, the 4 moves possible we have, and keep putting 0 until we reach 0. That's what fluid fill does, right? So we would return this to 0. We will go down, turn this to 0, go down, turn this to 0, go down again, turn this to 0, and then we will also go left, turn this to 0, then here, turn this to 0, turn this to 0, or even if we had 0, 0, 0 here, we would also go to the boundary here and fluid fill it to 0, right? And so, reachable from a boundary, so in our definition here, reachable from a boundary here, this means all 4 types of boundaries, right? We have, because the boundaries here are the top row, the bottom row, the left corner, and the right corner, right? And so all 4 types here, what I mean by that is top row, bottom row, left column, and right column, right? Of course, rightmost column and leftmost column, right? And so if we do this, if we fluid fill all those reachable from the boundaries with 0, then all that's left is just count the remaining ones, right? So this would be step 1 here. So this would be step 1. Step 1. And then our step 2 would be count all remaining ones, pretty much, and that we could return that because that's all the length squares that are not reachable from a boundary of value 1, and that's exactly what we want. So pretty straightforward, just 2 DFS just 1 DFS to replace all the fluid fill all the ones reachable from a boundary of value 1 with zeros, and then a final just counting all the all the ones values left in the matrix, right? So if we write the code here, should be pretty straightforward. So we need, let's say, number of ones not on boundary or something like that, and we get a matrix called A. Okay, so our first step needs to be we need to define definitely a DFS function here that needs to be passed the initial row we are traversing. So for example, here it would be 0, 1, 2, 0, it would be 0, 2, right? And so here, let's call it DFS, that gets 2 things, I, j, right? We could also call it fluid fill, right? Let's leave some space for that function, and then here, let's come down here, so that would be, or here, and we will need to start the DFS that float fills for all the ones on each boundary, right? And so first, let's just take care of the row, last and let's take care of last and first row, right? So for those, well, we could just say for, right? I is going to be either the first or last. So 0 or last, which is, let's just define two variables here to keep track of the number of rows and the number of columns. So length of A and length of A0, right? And then now here, so this would be rows minus 1. So either the first or the last row. And then after that, we'll come here for the J, which is going to be all the possible J because we are doing a row here. So this would be a range of columns, right? And for each of these, if the value is 1, we are going to DFS so that we can float fill it, right? And so we are going to say here DFS of ij. But we need to check, sorry. We need to check if it's 1 first. So we say if the element at aj is equal to 1, then we need to float fill it. So ij. And then once we are done with this, we need to do the first and last column, right? And so that would mean here we say, so here first and last column, and we need to go through those. So first we need to go through for J, first and last column, that means 0 and columns minus 1. And then we need to go through every row to go through the column here. So that would mean for I in range of rows, right? And then we will do it for every cell that has at the boundary that has value 1. So if the value is 1, then we float fill. So DFS of ij here. And once we do that, we are done. We can start counting the number of remaining ones. So this was step 1, right? So this here was step 1. Then after that, well, let's do step 2 then. So step 2, count all ones, right? So that would mean we can just go through every cell and just count, right? So that would be for I in range of rows, and for J in range of columns, we can just say if aij is equal to 1, or instead of doing if, because the other values are just 0, well, we could just initialize res here equal to 0, right? Or let's call it count, that would be better. So we would have count here, initialize it to 0, and here just count the value. If it's 0, we would add nothing. If it's 1, we would add 1. And then at the end here, we can return count. And now the only thing remaining is to do the DFS here. Okay, so our DFS here will need to say first, if the value is 0, just exit, right? Because we don't need to check anything at that point. But just before that, we need to check the boundaries just so that we don't get a wrong index issue. So the boundaries are if not in boundary. So let's define what does it mean for I and J to be in the boundary. So it would mean that I is within the range. Let's write this in a more Python way. So I, and this is rows, right? And J is within columns, right? So this is within the boundary. If it's not, then we can just return. That means we will cut off the boundary. If the value also is 0, we should stop because our float fill with 0 values is done. So we can return at this point. We could also like just merge these two here. Let's actually do it. So could do this, or aij is equal to 0, right? At this point we return, and then we float fill, which is the goal of all of this DFS is to replace the ones with the zeros, right? The ones reachable from the boundary. So we assign 0 here, and then we go through the neighbors. So to go through the neighbors, let's call them Ni and Nj. In it's going to be I plus 1, so going down, and then going up, and then going left, or going right, and then going left. Let me just fix this here. Going right, and then going left. So for each of these, we just call DFS. We are already doing the check for the boundary at the beginning here, so that would mean like this. And that's pretty much it for the solution, right? So just the first step here with the float fill part. So this is our first step. And this is just the definition of the float fill function itself. And then this is our second step, right? And that's pretty much it. Now let's see a little bit here the time complexity and the space complexity we are working with. So in terms of time here, we are doing, this is for example O of 2, of course, so that's fine. This is O of, if we say the columns are M and the rows are N, then this is O of M. Same thing, O of 2 constant here. This is O of N though, right? And then for the DFS, we do at most, like we would have ones like the entire matrix has 1 values, right? So we would do at most of all the cells, so at most of an M, right? But if we do O of an M for the DFS, then that would cover for this entirely, because we would have float fill with zeros, and the next iteration would finish really early with 1 iteration, right? So that means overall what we are doing here is O of n M time. And if we look at space, this is using a stack with the DFS, so it's the same in terms of space as well. Okay, so that's it actually. Let's run this on an example and make sure it passes. Okay, so I wrote down the solution we saw in the overview here. So we just set up like the rows and column size. We go through the first and last row, and we float fill using this DFS function here, and then we go through the first and last column and we float fill as well. And float filling here is just first checking if it's if we went outside the matrix, then with the indices here, then we return. Or if the value is 0, then we return as well, because we can no longer reach ones from there, because the only way to reach 1 is to be continuously going from 1 at the boundary to that value 1, right? And so if it's 0, that means we can't reach any more ones, so we return and we float fill. This is the goal of the DFS function, is to set the ones that are reachable from the boundary to 0, and we go through the neighbors, all the neighbors in 4 directions, up, down, left, right, and we call float fill on them, right? And then at the end, once we did that, the only remaining ones are ones that are not reachable from the boundaries, so we count them up. And here I'm just adding plus, because if it's 0, it won't add anything, so we will get only the ones, and so we can return count here. I have some test cases here that just to sanity check, and all of them pass here. One thing we can improve this with is actually we can just use here a quick Python sum function here. So just say sum of aij like this for ij like this, and then just return that instead, right? So this should still pass fine. It does. Yeah, so that's it pretty much actually for this solution. Yeah, thanks for watching and see you on the next one.